We've been at the forefront of automotive engineering innovation from the beginning, from the Model T to the fully autonomous vehicles of today. With the next automotive revolution happening right before our eyes, SAE's quantifiable research and reliable technical documentation are more crucial than ever. Connected vehicles, electrified vehicle technology, and sustainable transportation are just a handful of the areas where SAE International supports those who shape the future for the mobility of tomorrow. With more than a century of experience, a powerful and growing cohort of shared knowledge, backed by a global community of more than 200,000 engineers, technical experts, and volunteers, SAE continues to curate the most reliable and comprehensive collection of engineering resources and consensus-based mobility standards on Earth. Movement defines life. SAE lives to define movement.
Hey, welcome everybody. This is Mark Zachos, and today on our program we have another special guest, Jeff Jaczkowski. He's the Associate Director of the U.S. Army Ground Systems Cyber Engineering over here in Warren, Michigan. So Jeff, hey, thanks for joining us today. Welcome.
Hey, Mark, thank you. It's a pleasure to be with you all, and I want to extend my thanks and appreciation for the invitation.
Well, you know, we've been in the southeastern Michigan. I grew up here all my life. Always knew what was very proud of in our region here is that facility that you all have there, the Engineering Center in Warren, off a 12-mile, and well, it was called what, TACOM, TARDEC. There's something different now, right? So can you start us off there? You know, why did you guys change the name? That just happened about a year ago. So
certainly, yes. So you know, that's quite interesting. I'm a southeastern Michigan native myself, as is much of my family. I've been at the Detroit Arsenal since 1988, and throughout the years, the number of friends and family members that I've had to educate that, you know, there is this postage stamp slice of heaven in Warren called Detroit Arsenal. So we are known as the Detroit Arsenal, and collectively known as the Tank Automotive Command Community. The research center that I am part of is the Ground Vehicle Systems Center. And as you alluded to, we used to be called TARDEC, the Tank Automotive RD&E Center. About a year and a half ago, our parent command, which is now called the Combat Capabilities Development Command, or DevCom for short, all of the 7 R&D centers within the DevCom took new names. So ours went from TARDEC, or the Tank Automotive Research Development and Engineering Center, to the Ground Vehicle Systems Center very recently. So again, we are a Department of Defense of the Army service. So in Army installation, over 6,000 logisticians, engineers, scientists, contracting specialists, program managers, all co-located at the Detroit Arsenal. Collectively, our mission is to equip, field, and sustain and perform the research and development for all of the Army's ground vehicles and ground vehicle support equipment.
Mm-hmm.
Our DevCom's parent organization is called the Army Futures Command. It's located in Austin, Texas. AFC for short, the Army Futures Command has the mission of accelerating and operationalizing requirements and technology. So taking the best and brightest of what we're working with industry and academia and government labs, driving that into the hands of the warfighters for early and often experimentation to get that into the field, to modernize the Army's and focus on the Army's modernization priorities.
Yeah. So one of the things that we're going to talk about on the next slide is next few slides are cybersecurity, and that's directly your area of expertise. So in the bottom line, what do you all do? What's that collaboration between the industry and the government and your center there? What are you guys looking for to work with our community here? And it's not just in Michigan, but throughout the country, right? Industry has a lot of competencies, and I think it's also a two-way street.
Yeah, absolutely. That's a great question, and our bottom line here at Ground Vehicle System Center in the Ground System Cyber Engineering, the bottom line, plain and simple, is that we need to cooperate and co-develop technologies and share best practices, as well as threat information across both the commercial and military sectors for a number of reasons. And we'll get into the parallelisms and the similarities between an Army green truck or tank and an OEM vehicle, but they are starkly similar. As we continue to see technology being operationalized, or OT, operational technology, and being added to our vehicles, right, the attack surface and potential latent vulnerabilities in our vehicles, it explodes. Mm-hmm. So that is really the whole foundation of the team of Ground System Cyber Engineering that I lead at the Detroit Arsenal. We are charged with three things. One is ensuring that we are advancing the state of cyber resiliency in our weapon systems. And when I say weapon system, I mean tanks and trucks, basically. This weapon system is a broader term that we use. Secondly is we do that in a number of fashions. One is we have a vulnerability research team, and conducting continuous pen testing, identifying vulnerabilities that can then feed into our technology development. Mm-hmm. And then in pursuit of that technology development, we realize that the team that at Ground Vehicle System Center, we absolutely need to go out there and find the cutting edge, the emerging technologies, the innovation that is out there in small business, in non-traditional companies, in our tier suppliers, as well as OEMs. So we understand we can't do it alone, and this whole cybersecurity domain in getting it right, or getting it righter, is essential to both our economic and national security going forward. I truly believe that. There's the transportation, the automobile sector, the trucking sectors, and our military vehicles are part of that priority. Mm-hmm. And we need to do it collectively and together.
Yeah, so the advanced public-private partnerships, as you mentioned here, and the co-investment and the research, that all really fits together. So it sounds like you're in the right place at the right time for helping our industry that I reflect on that as the automotive industry, and vice versa. We can the industry can help what you all are doing. So on the next slide, you have, I think, pictures of some of the, there's a truck there, there's a 18-wheeler there in the lower left, and then there's a looks like a Hemet truck there, and then the right side there's a commercial vehicles, private vehicles, robots. Could you talk to us a little bit now about how the synergies here as you see them mapped out?
Yeah, absolutely. And these the pictures that I selected here, the specifics of the actual vehicle really isn't important. What I'm trying to illustrate here, on the left-hand side, the vehicle cyber physical systems, where I show, I'm showing the commercial truck and a military truck, which happens to be a heavy expanded mobility tactical truck, is that the both of those systems reside on a 1939 data bus. They employ the exact same data bus and data architecture. The ECUs that we find in the vehicles are strikingly similar. From Detroit diesel engines and Allison transmissions, Abaco brake systems. So as we peel back the onion in terms of the cyber physical piece, again, we are utilizing industry components and bringing those into the military sector and hardening them to some extent. And on the right-hand side, showing the Google Maps car and that's on the bottom. There's a mule, a robot, but basically, again, it's that adding on sensors and connectedness and autonomy. All of that again stresses and exacerbates the really the need for this focus on one, buying in to this notion that there is no such thing as an impenetrable cyber defense. If you look up the Maginot line in the dictionary, it says something like a formidable static defense that provided false sense of security. And really, we need to get. And I think the community is moving way beyond that hard outer shell and this notion of resiliency and having the ability to adapt and have layers of defense. And so beyond cyber physical systems, a huge part of this is software assurance. And when we talk about software and the millions of lines of code that are going into our vehicles these days, and where some of the open source code repositories are being populated from, and the provenance of that software, and the potentiality of buffer overflow being hidden in a million lines of code and trying to detect that, or worse, right? Supply chain with counterfeits, or again, supply chain coming in with embedded malware or altered firmware. These are all things that both the military and industry sectors are dealing with, and working together on this common front across all of these areas is essential.
So I notice on your next slide here coming up is some of those areas in specific, the intrusion defense systems and vehicle data bus encryption and hardware security modules. All those things look familiar to me, being working in that industry. I probably you could talk in more detail on those. I'd like, though, to keep you on that theme of resiliency for a moment, and redundancy and graceful degradation. In automotive, we've got this thing called a limp home mode. If the car doesn't run, something's missing in the sensor data or whatever. You guys, your missions are life and death, though. You got to make sure that those soldiers come back home. So maybe there's a little bit of similarity and some differences you could talk about too.
Sure. Yeah, certainly. Mission assurance is essential. Having the ability to detect, isolate, or adapt to a particular cyber attack, again, is important. As important for mission assurance, as well as soldier and system survivability. So the kinetic threat that we've been the military has been dealing with and addressing through thicker armor or active protection or greater mobility and agility, just like that, we have to deal with cyber bullets. And how do we do that? And how do we do that? Maintaining agility and flexibility, maintaining the ability to move, shoot, and communicate, and our full functionality so that kind of gets to some of the things that we're talking about on the next chart. We highlight here, these are a few examples of some of the technologies that we're currently working on, and we have teamed with a number of industry partners to develop things like intrusion detection and prevention, again, focused on the automotive bus, if it's 1939, or the CAN bus, or a lot of combat systems like the M1 Abrams main battle tank or the Bradley infantry fighting vehicle employ the 1553 data bus, which is from our avionics community. We also are looking at things like machine virtualization, as well as employing security features built into some of these next generation ECUs through software. A number of different approaches on our intrusion detection and prevention capabilities, things like bus segmentation or digital fingerprinting. But again, we're looking with industry and academia a number of different approaches that all have the same end state in mind. And as I mentioned up front, part of the Army Futures Command, we're part of that family. It is early and often soldier interaction and operational experimentation. So maturing the technology, prototyping it, integrating it into our vehicles, and then getting that into experimental venues for assessment and operational feedback. Again, what happens? What does a soldier do? What is the response tactics, techniques, and procedures upon detection of a cyber attack on that soldier's vehicle? What does the soldier do? Does the soldier have an interactive role, or is it completely automated? Right? These are things that we are figuring out right now about the level of involvement or not, and then what do we do with that data? Right now, we don't have a pipeline to the cloud or to a cyber security operations center that is aggregating attack data out in the wild and bringing that in. So as we move in that direction, building a secure, maybe bi-directional, secure over the air, so we can extract that data, do forensics, also use that over the air for patches or firmware updates. But these are some of the things that we're currently looking at. to improve ground vehicle cyber resiliency.
So let's stay on the theme about, how do we test this out? Because as a good engineer and a program manager, you get all these great ideas and the collaboration with industry. And I guess we could go over to Aberdeen at the proving grounds someplace and shoot things up and drive it around, test it up. But there's something here on your slide that has to do with a local test facility, something called the KVIC. Could you talk about the KVIC and the Cyber and Connected Vehicle Integration Center? That seems like a really interesting idea too, huh?
Yeah. So testing, that's a great question, and I think we'll probably preach into the choir here, but early, often, and continuous, right? Building it in early, doing component level assessment and testing, and then as we define the system boundary or the information system boundary, what that looks like from a assessment and test perspective. As important is what are the metrics? What are the metrics that we are assessing? What are we trying to gather? Is it, for intrusion detection, is it, true positives, false positives? What are the right metrics we're trying to gather? Through penetration testing, I think there can be some standardized testing, at least similar battery of pen tests that could be done in conjunction with, in our world, the developmental test and operational test. And obviously, when we get to, from the cooperative testing into more of the red team or true adversarial testing, we don't want to hamper the red team, right? And go, here's the battery of tests you perform. When we get to that red team operational test, trying to really emulate the adversary and the thought process of the bad guy, right? They should have that freedom of maneuver for what they do. Something like the KVIC, the Cyber and Connected Vehicle Integration Center, is right now it's a concept where we envision brick and mortar to bring together the community of all the players and stakeholders that I've alluded to through the course of the last 15 minutes. The military in particular, Ground Vehicle System Center, other government labs and agencies, maybe like Army Research Lab or the Air Force Research Lab, maybe some of the intelligence community, but more importantly, that industry participation in academia, where collectively a number of things happen. One is co-development and co-investment of some of these maturing technologies, integration and testing into both commercial trucks or commercial vehicles and military vehicles side by side. Again, for the same reasons that we talked about. The similarities are strikingly we're dealing with a similar problem set, and in many instances, similar hardware. The threat space in sharing, so the KVIC goes beyond sharing of information, where there is side-by-side development, testing, and integration and feedback in transition of that knowledge and capability and technology into both military and commercial ground vehicle fleets.
Yeah, and where else in the world can we do this? I mean, this is the place, and it seems like such a great idea, and I hope it really grows and matures and gets traction someplace. Maybe on your facility there in Warren, or maybe up in at Selfridge. This would be a great location for this KVIC center. So
yeah, certainly Southeastern Michigan is the right place with the coalescence of the automotive OEMs, all the suppliers, the academic base that we have here. If it's at the Detroit Arsenal or Selfridge, I think southeastern Michigan is a right spot for ground vehicle community to come together to tackle this tough problem.
Right.
It's the same reason why Detroit Arsenal was established in Warren, during World War II, right? The TACOM, or Detroit Arsenal, if you've heard the Arsenal of Democracy,
Right.
it was founded in Warren to bring to bear all of the automotive firepower to World War II, and started cranking out Jeeps and tanks for the war. And that's why we're here. 70, 80 years later, this is, the KVIC, it's the same rationale, right? We're here. This is the right thing to do for the warfighter. This is the right thing to do for our passenger vehicles, our transportation vehicles and transportation industry.
Right. So we're going to summarize here, and on the next slide, you do have a great wrap up here, and again, it comes back to the national cyber workforce. There's a lot of development there that we talked about, the technology. One other thing that's also important is that workforce, the workforce development, and the new generation coming up. Like your children. My daughter is in college now. She goes to the University of Michigan, software engineering, working on cyber. This is our next generation. University of Detroit Mercy now has a cyber applied cyber vehicle center. So bring the technology up, bring the industry, automotive industry together with DoD, but let's bring our kids and our families and that next generation together in fighting this threat. It's a national threat, isn't it, Jeff?
Yeah. As they say, a rising tide raises all ships, and the need for cyber talent, is just growing. I think as we cooperate and work together more and more, one, as you pointed out, the emergence and continued growth of automotive cyber specific curricula in our local universities, and making that available to workers that we currently have that don't have that experience, that they can go and get advanced degrees, or those institutions turning out young scientists and engineers that are eager and now knowledgeable in the domain, essential to our progress forward.
I think we've learned a lot here from this session, and we'll really appreciate the time and you take away from your day job here to sit together with us for a few minutes. We hope our audience here enjoyed the information. For more details, we'll put the contact info for the SAE Detroit section up there. You can email, you can catch this on social media, you can tweet some things out. If you have some questions, we'll try to respond. But thanks for joining us, everyone, today. Thank you again, Jeff. And of course, thanks to our men and women in uniform. And we all do greatly appreciate your service, the veterans as well. So until next time, Mark Zachos here, and hope to see you on the next session of our Supercharged pod.
Thank you for having me, and thanks to SAE for the invitation.